Alright, so what we're going to work on today is the population genetics by Weinberg. So we're going to be looking at this paper, which you should be able to find on my website. We're going to mainly be looking at this equation here, the Hardy-Weinberg, p squared plus 2pq plus q squared equals 1, and then you always know that p plus q equals 1 as well. You need to make sure that you have memorized all of this information right here, because these are what each variable always stands for. And these are going to be the variables that you're going to have to find for each problem. You'll have to find p, q, p squared, q squared, and 2pq. So as long as they give you one of these 5, you should be able to find the rest of them. So with this in mind, up here, we are going to work problem number 1. So on the back side of this sheet, so all I did was flip it over, and I've got 2 here just to make it a little bit easier to when I come back. So looking at question 1, we know that the AA allele is 36, and we're going to call it 0.36 because it's a percentage, and we're going to move it down, move our decimal places 2 places to the left. So if you look up here, little a is homozygous recessive. So if you look here, homozygous recessive is q squared. So that means q squared equals 0.36. So knowing that q squared equals 0.36, you can use a calculator. Don't try to use it in your head. And do the square root of 0.36. So 0.36, and then we will do a square root of that. And you get 0.6. So that would mean Q equals 0.6. So the frequency of the AA genotype is 0.36, which they gave us. The frequency of the little a allele, so if you come up here, frequency of the recessive single allele is equal to Q, so that's where we got that. So Q equals 0.6. Now, they need to know frequency of the large A allele. So you come up here, frequency of the dominant allele, or the large A in this case, is P. And we know that P plus Q equals 1. So P plus 0.6 equals 1, so you subtract 0.6 from both sides. P equals 0.4. Now, the next question is the frequency of genotypes big A, and big A, little a. So I'm going to come down here and I'm going to write big A equals big A, little a equals. And we know that big A is homozygous dominant. So you come back up here, P squared percentage of homozygous dominant. So big A equals P squared. Big A, little a is heterozygous, so heterozygous is 2PQ. Okay? So P squared, what was our P? 0.4. So we're just going to come back, put that in our calculator. So 0.4 squared equals 0.16. And then 2PQ, so we'll take 2 times P, which was 0.4, times Q, which was 0.6, equals 0.48. So big A, little a, and I'm just going to put it right here. We got 0.48. Okay? So big A equals 0.16. Big A, little a equals 0.48. Now, the frequency of the 2 possible phenotypes. So our 2 possible phenotypes, big A, and big A, little a, will be the same. So I'm going to say phenotype 1, which would be big A, or big A, little a. You just add those together. So you're going to do 0.16 plus 0.48, 0.16 plus 0.48 equals 0.64. And then we already know the other phenotype is little a, and we already know that that equals 0.36. So plus 0.64, that equals 1 if you add them together. You also notice that P plus Q should equal 1. So Q plus P equals 1. So that's how you're going to check yourself. So that's how you do sample problem 1. You're just checking your variables up here and doing the math down here.